guys, and welcome to our new video. Today we will discuss part 2, notes of chapter Force and Laws of Motion. If you have not seen our part 1 yet, then watch the video link given in the description. Let's start our discussion. Derivation of Newton's second law of motion. Suppose an object of mass m having initial velocity equal to u, final velocity equal to v, time equal to t, and applied force equal to f. Then initial momentum p1 equal to mu. After time t, momentum p2 equal to mv. Change in momentum equal to p1 minus p2 equal to mv minus mu. Then rate of change of momentum equal to mv minus mu by t. According to the Newton's second law of motion, force directly proportional to the rate of change of momentum, or F directly proportional to mv minus mu by t, or F directly proportional to m whole into v minus u by t, or F directly proportional to ma, or F equal to kma, where k is a constant of proportionality. If 1 unit of force is applied on a body of 1 kilogram to accelerate 1 meter per second, then value of k equal to 1. Hence, F equal to ma. The SI unit of force is Newton. Application of Newton's second law of motion. Catching a cricket ball. Cricket player or fielder moves his hand backwards on catching a fast cricket ball. This is done to prevent injury to his hands. We can explain it as follows. A fast moving cricket ball has a large momentum. In stopping or catching this cricket ball, its momentum has to be reduced to zero slowly. Now, when a cricket player moves back his hands on catching the fast ball, then the time to reduce the momentum of ball is increased. Hence, small force is exerted on the hands of the player, so his hands of player do not get hurt. If, however, a cricket ball player stop a fast moving ball suddenly, keeping his hands stationary, then the large momentum of ball will be reduced to zero in a very short period of time. Due to this, the rate of change of momentum of cricket ball will be very large, and hence it will exert a large force on player's hand. This player's hand will get hurt. Catching a cricket ball. See guys, here you can see how the cricket player or the fielder catches a cricket ball. Newton's third law of motion. Statement. Every action has an equal and opposite reaction. For example, when a bullet is fired from a gun, the force sending the bullet equal to the force sending the gun backward. When a man jumps out of a boat, the bank of the river, the boat moves backward away from it. Now we will discuss conservation of momentum. What is the law of conservation of momentum? When two or more bodies act upon one another, their total momentum remains constant or conserved, provided no external force are acting. This law of conservation means that whenever one body gains momentum, then some other body must lose an equal amount of momentum. This law can also be stated as momentum is never created or destroyed. Or the otherwise we can describe it. Sum of momentum of the two objects before collision is equal to sum of momentum after collision, provided no external force is acting on them. Mathematical derivation of conservation of momentum. Suppose two objects A and B of mass m1 and m2 are traveling in the same direction, longest straight line, and velocities u1 and u2. These are the initial velocity of the two objects respectively. Let u1 greater than u2 and the collision lasts first time t. Object A exerts a force F1 and F2 on object B. Similarly, object B exerts a force F2 and on object A. And let their final velocities after collision are VA and VB respectively. When the force F1 of the truck acts on the car for a time, then the velocity of the car changes from u2 to v2. So, acceleration of the car a2 equal to v1 minus v2 by t. But force is equal to mass multipliers acceleration. So, the force exerted by the truck on the car is given by F1 equal to m2 into v2 minus u2 by t. When the force of F2 of the car reacts on the truck for a time t, then the velocity of the truck changes from u2 to v2. So, acceleration of the truck A would be v1 minus v2 by t. But force is equal to mass multiply acceleration, so the force F2 exerted by car on the truck is given by F2 equal to m1 into v1 by v2 by t. Now the force F1 exerted by the truck is the action and the force F2 exerted by the car is the reaction. But according to the Newton's third law of motion, the action and reaction are equal and opposite. That is, we can write F1 equal to minus F2. Now, putting the values of F1 and F2 from the equation 1 and 2, we get m2 whole into v2 minus u2 by t equal to m1 whole into v1 minus u2 by t. Cancelling t from both sides, we get m square whole into v square minus u square equal to m1 whole into v1 minus u2, or m square v square minus m2 u2 equal to m1 v1 plus m1 u1, or m2 v2 plus m1 v1 equal to m2 v2 plus m1 u1, or m2 whole into v2 minus u2 by t equal to m1 v1 plus m2 v2. Total momentum before collision equal to total momentum after collision. From this, we have concluded the conservation law of momentum. If you want to see some sample questions of this chapter, then tell us in the comment box, and if you want any other content, you can write in the comment box. This was about our whole video, and wait for the next video.